Hello. In one of my previous videos I've described discrete waves, waves of probability that appear in discrete universe, where particles can move only in limited amount of directions and the amount of those directions depends on the amount of the discrete pieces of a particle. The more directions particle can move in, the lower is the distance between possible positions of particle after 1 second of movement. That distance I've called the discrete wavelength of a particle. Link to that video is in the upper right corner now. Today I will show how discrete waves cause dispersion or rainbow. Let's assume that particles can consist of discrete pieces with one of 4 possible directions of movement: left, right, up, down. Let's assume that we have 2 sets of particles. Each particle in the first set consists of 5 discrete pieces with direction up. Each particle in the second set consists of 8 discrete pieces with direction up. So we can say that the energy of each particle in the first set is 5. Energy of each particle in the second set is 8. Each particle moves up with constant speed and we don't see any difference. Let's add 1 discrete piece of random direction to each particle of both sets. As a result, some particles get discrete piece with direction left or right and change the direction of their absolute movement. But particles with more energy change the direction of their absolute movement less, as their discrete wavelength is shorter. I've explained that in the video mentioned earlier. So particles with different energies have different discrete wavelength and different directions of movement. We can add more random discrete pieces into each particle and see that discrete waves of different wavelength appear as a result for the first and for the second particle sets. Now let's make a rainbow. From physics we know that real photons from visible spectrum of electromagnetic radiation have different wavelengths and different energies. We can emulate dispersion or rainbow phenomena by assigning particles specific initial amount of discrete pieces and specific color. We can set initial amounts of discrete pieces and color to be proportional to corresponding energies and colors of real photons that we know from physics. After that we can check how particles of each color would behave. Particles that consist only of direction up behave the same way whatever energy they have. But after we add the same amount of random directions to each particle, we get the dispersion or the rainbow effect. This rainbow effect looks quite similar to a real rainbow. Please note that it's not a real rainbow, only its discrete emulation. Real rainbow is caused by effects like diffraction, which have more complex nature. I had a separate video about interference, diffraction and the double slit experiment. Link to that video is in the upper right corner now. Unfortunately I don't have theory of everything yet, therefore I cannot generate a real rainbow from a double slit experiment. It will have to be done in future. Again, the discrete wave I've described and the wave of probability physicists speak about are not the same, they are very different. But according to my assumptions they are both caused by the discrete nature of our universe and by the constant speed of all matter in it. The larger the energy of a particle, the more discrete pieces in it and the less is the contribution of one particle into its absolute movement. And we get the rainbow effect as direct consequence. Therefore it might happen that when physicists speak about wave nature of matter they actually speak about its discrete nature without even knowing that. In next videos I will try to explain you de Broglie wavelength and Compton wavelength. But it might happen that those really are de Broglie discreteness and Compton discreteness. Yes, physicists don't know, ChatGPT does not know. But there is a possibility that now you know. Thank you for your attention.